Alright, so 2002 Jetta with a VR6. Customer complaint is a misfire where it runs rough. Did it stall? It was stalling?
Sure.
A little bit of history on the vehicle. My friend Tony bought this car and it came from another shop. They told the previous owner to do spark plugs, wires, and a coil, and if that didn't fix it, then it needed a computer. So the owner did the plugs and wires themselves, and it didn't fix the car. The vehicle runs. We do have a misfire. Don't worry about this harness. It's a little haggard. But so that's what we're after. We're after a misfire. So these faults we have stored at injector cylinder 6 N84 circuit malfunction. It's a P0206, and then we also have an injector cylinder 1 N30 short with power, P0262. Alright, so I'm just under expert mode, and what I'm going to do is measure value block. I want to bring up my misfire counters. Misfire counters are 15 and 16. So there you have your channel 1, 2, 3, those are your cylinders. And when you hit 16, there is another count right there. So I'm just going to start this thing up. So we have one count on cylinder 1, another one on cylinder 6. It's not registering right now, but so what we're going to do is a cylinder drop test. Confirm these. Okay, so we're just going to start out with a cylinder drop test, and I'm going to connect my test light to a ground. Alright, go ahead and fire it up, Tone. It's good. As long as I keep my test light closer to my hand, I won't get zapped. That is see the cylinder drop. Oh. Try it again. It's a good cylinder right there. Lower one down here. It's a good cylinder. Good cylinder right there. So this looks like number 6. No RPM drop. Definitely do have spark. No RPM drop on that one either. So that is cylinder 1 right there. And cylinder 6. No RPM drop, cylinder 1, cylinder 6. Alright, Tony, you can kill it. Alright, so lucky for us. You don't mind being on camera, do you, if you are? Oh, no. You're in there. Alright, so lucky for us, this computer is already exposed, and what we're going to do is just do some checks on these injector wiring right at the computer. So I have our wiring diagram right here. So our injector faults, we have this is cylinder 1 right here, N30, which is connector 121/96, so pin 96. It's a lilac wire, that is the control side. All these injectors share a common feed from the fuel pump relay. So the wires that we're looking for, a lilac, which is pin 96, and then we are looking for a green and yellow, which is pin 89. So that's what we're looking for. It's right here. So right here we have solid lilac. This is our injector number 1 control, and then this green and yellow, which is our injector number 6 control. And we're just going to do some voltage measurements right now. Key on, engine off. So I'll just connect up to this injector number 1 control wire first. Is that key on?
Yes, sir.
It is?
Mm-hmm.
Yeah, I got the timing cabinet out in the garage up on yours. I got that other cabinet that I just brought out yesterday. I got that in the...
Alright. You want to start it up for me? Alright, so we are hooked up to this cylinder number 1 control wire. To get you voltage reading on the scope. Time base milliseconds, and I will set a trigger up right there. Screen. Alright, so what we want to see is our battery voltage, feed voltage, and when the computer turns this driver on, it gets pulled down the ground. What you have is a magnetic field, a big spike right there, and that's what we don't have right now. There's no magnetic field, no collapse. What I want to do on cylinder number 1 injector is take an amperage reading, and then we will move on to cylinder number 6. So I'm going to leave this running and set up my other channel with an amp clamp. That's a shorted injector, man. That's good and sweet right there. And my time base. Alright, so I have my amp clamp hooked up along with my channel 1. The yellow lead is on my injector control on the computer, and I have my amp clamp around the control wire. And what that waveform shows us is that we have a shorted injector on cylinder number 1. So there's no build, there's no magnetic field. So cylinder number 1 needs a fuel injector. And now we need to move on to cylinder number 6. I'll just turn this channel off real quick. Right there is our injector control. No big spike, that means there's no magnetic field to collapse. And our amperage waveform proves it that we do have a shorted injector. So, on to cylinder number 6. Alright, so I still have my amp clamp hooked up. This is on the cylinder number 6. This is a green and yellow wire. Let me get you a shot of that real quick. So we have channel number 1 is on the control, and the amp clamp also hooked up on this control wire to take an amperage reading. And what we are reading is 3.67 volts on this control wire. And there is no coil control, or no injector control. So this injector is not firing. The question is why isn't the injector firing? Is it because of this feed voltage and its intentional shutdown by the computer? Or do we have a feed voltage and a computer problem? So, well, right off the bat, we know we have a feed problem. 3.6 volts, it should be at least 12 or battery voltage. And the computer's not firing the injector. Alright, you can kill it. Got an idea. Alright, so what I want to do, I'm going to take my test light and connect it to battery positive. And I'm just going to touch on this pin. What I want to do, I want to trick the computer into thinking that this circuit is okay. Turn this around there. I'm going to leave my test light hooked up to this. And I'm going to bring the supply voltage. You see my supply voltage jumped up. So I'm just taking my test light, battery positive, and tell him if you could just jump in and start this up. What I want to see is my test light flicker right now.
Ready?
Yeah, go ahead. See, we now have control when we had it for a sec. My test light is flickering very lightly. Alright, you can kill it. Ah, sweet. Alright, so hang on. Stay in there real quick. Alright, go ahead. Fire it up again. The camera's picking that up. We now have control. It's so dim. Well, you can see the test light flickering. That's good. That tells me my computer's okay, and what we need to do is chase this power feed problem. All right, kill it. No, you can leave it off right now. Dude, sweet. That's your problem, Tone. That's supply voltage.
Yeah.
So as soon as we turn the key on, the computer sees that 3 volts, that 3.6 volts that we have, or
Yeah.
3.5.
So I don't need an injector? Or I still need an injector?
Not sure yet with that.
Oh, okay.
What we need to do is fix this supply voltage. So what the computer sees that 3.5 volts, and it's like, well, I don't like that, so I'm not even going to turn this injector on.
Okay.
So what I did is I tricked it with my test light.
Okay.
I put my test light to battery positive, and if you watch this, when I do that, this voltage jumps up to battery voltage.
Okay.
So then the computer thinks that the circuit's okay.
Okay.
And I was actually getting a flicker with my test light.
Alright, so we basically have to run a new wire from here down.
Or find the issue.
Okay.
So,
What one on the purple wire?
the green and yellow.
Green and yellow. Okay.
Yeah, so cylinder number 1, which is the purple wire, needs an injector. Absolutely.
Okay,
No
so
question.
we do need an injector. That's
Yeah,
what
no
I-
question about that. Definitely needs an injector. What we need to do is take a reading down at the injector and see what kind of feed voltage we have down there. Because we're looking at a wiring problem.
Which is a good thing.
Alright, so Tony's partially pulled off this front end, and what we need to do is get this intake off to access the injector harness that runs underneath the intake. Great design. So what we should do right now is get this intake off.
Okay. I'll have to check right here the wires.
Well, if we go, before you cut that, you know, we may have an issue right underneath here.
Okay. What do we need to get that off, sir?
Let's see here. Let's pull these plug wires. pretty easy, but they're new. Somebody just replaced them for no reason. So I'm gonna slide those over there. Yeah, there's a few Allens down there. Get this cone hose out of the way.
Okay.
There's that line right there. It's free. You just gotta bring it around town. There you go. All right. Nice. All right, so we got our intake off, thanks to Tony and his slow-moving arms. Just kidding. What we're gonna do right now is take a voltage reading. This is our cylinder 6. It's hard to see, but there is a green and yellow wire in there. And what we're going to do is take a voltage reading right there and see if we have that same, was it 3.5 volts? So if we do, then we know that the problem is on our feed side. Well, that makes sense. It would have to be on our feed side. But we'll take a voltage reading and go from there. But all these injectors right here share the same feed, so there's going to be a splice somewhere in this harness. So maybe a bad splice. So take a voltage reading. That's good. Let's see what we got there. You want to turn the key on for me real quick?
I'll get out of Ian's way. If you need me, let me know.
Alright. Key is on.
Key's on. You know what sucks?
Huh?
I think that this only sends voltage when,
The car is running.
yeah, when it sees like a crank signal or an RPM signal. Well, it's got to be in here because it has to be in here because all these injectors use the same splice right here. They use the same feed.
Okay.
You know, if we had a power feed issue on this side, the car just wouldn't run.
Exactly. So it has to be this green and yellow wire.
No, the green and yellow is the control.
Okay.
What it has to be is the power feed, which is on this side, and it's all in this splice right here.
Okay, so should we cut that open?
I wish we could start the car.
Look right there.
That's for this injector.
Oh.
Oh, I wish we could run the car. That would be perfect right now.
Why is that so loose on the injector?
Maybe it's broke.
That's what I was. I think there's a broken injector.
It's possible. The camera can see that. This injector, the connector on the injector side, the actual head of this connector is wiggling. Wonder, dude, we could have an issue right there.
None of the other ones wiggle like that.
It is true.
That
That one, yeah, but it's just the connector. It's not the actual head of this injector like that. Alright, well, let's try a resistance of just the injector. We'll compare to another one. So this one right here, cylinder 5, about 15 ohms. Let's go to this one. And open circuit on this. What if I flex this? And get a connection. So maybe.
Bad injector.
Yeah, it could be. Let's do another one over here. 15 ohms. So two bad injectors. This one's, I guess, open. That 3.5 volts. That makes sense. But yeah, the main check I think was key. Was that checking that computer circuit, so that we know the computer's good.
Yep.
And they all share the same splice right here. it just sucks that we can't take a voltage measurement. You know?
Yeah.
If we could literally just run the car for a second, just make sure we have this 12 volts right here.
It won't air fire though, would it?
You know what? I wonder if we can just crank it. We have all the injectors. If we unplug all the injectors, they're not going to fire. We can unplug the coil. That won't fire. You know?
Yeah.
And then just crank it over. If I can do that.
They all unplugged?
Yeah, let me put my pin back here. I just want to make sure everything's out of the way. Everything's out of the way.
Tell me when.
I think we're okay, man. Everything looks out of the way.
Sure?
Yeah.
Okay, here goes nothing.
Go ahead. Alright, hang on. Okay, so we got all the injectors unplugged. We have all the coils unplugged. The problem with this design is that it gets power from the fuel pump relay, but it doesn't get power with the key on, engine off. It needs to see maybe a crank signal, RPM signal, something like that. So we have the coil unplugged. We have all the injectors unplugged. And Tony's just going to crank the car over and we're going to see what kind of voltage we get on this. So go ahead and crank the car, Tony. About 9.7 volts. Alright, that's good. Alright, and just for comparison, so that says that our feed is good and that this injector is actually open, which that makes sense. Hang on, I'm just going to go on another one to make sure we're getting that same 10 volts. Alright, so I'm on another injector. Go ahead and crank it. Yep. Alright, that's good. Alright, well that confirms it. Our feed voltage is okay. This has two bad injectors, one open, which would be on our cylinder 6, and you can see it right here. This connector is actually kind of broke, so I wonder if the pins are just screwed up in there. That's sure what it looks like. And then on our cylinder 1 over here, this one is shorted, and we knew that from the amperage waveform. So Tony wants to order a full set of injectors, which I'd be okay with. You're in here, why not do them? But two bad injectors. We were able to confirm that the computer control side is okay. It's just intentionally shutting down the circuit because of this feed voltage that it sees, and it's because the voltage is not making it through this injector. So one open injector, one shorted injector, and I will get the word from Tony after he puts all the injectors in and throws it back together. So two faulty injectors, one shorted, one open. This is our broken connector on the actual injector housing, and just to give you a comparison, we'll move over here, go to this one, and that one is pretty tight. It's not broken at all. So whoops.
Oh, it's really broken now.
It's definitely broke now.
Oh.
And
There she goes.
whoops.
Oh, to save that.
Sorry.
I could fix that with some solder.
You still can. Well, I hope you guys enjoy this video. Thank you to Tony for letting us film it. And I'll get his word after he puts it back together. And if we need to come back, then we'll come back. But I don't think we will, unless he needs help putting it back together. So, hope you enjoy. Thanks for watching.